Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, class EC1104G, and for today we are doing a video presentation on the topic of sustainable product development in civil engineering. Before we begin, I would like to give a bit of an introduction on this topic. There has been many research aplenty that's been done in concerning with producing a sustainable product which can be used in any civil engineering works that make use of non-conventional materials that are actually considered as waste, with the objective of making a healthier environment by making use of these waste materials. Not only are we decreasing the amount of waste in the environment, but some common materials in certain building materials are harmful and are from resources that are non-renewable, therefore making these studies and research much more crucial. In particular, we have chosen two studies that are studying on the use of a waste material as a substitute option for an aggregate as a constituent of concrete, which are the number 1 on the left, rubber crumbs of waste tires, and number 2 on the right, ceramic tiles. The theory behind using rubber crumbs of waste tires as an aggregate of the constituent of concrete is that there has been an increase of the number of vehicles on the road as automobile becomes much more demanding, and it has directly impacted the amount of scrap tires, which is estimated to reach 1.2 billion tons annually by the year 2030. Due to the nature of tires as a non-biodegradable product, utilizing and managing scrap tires proved to be a difficult task, therefore making waste tire management an arduous task, with tire waste posing as a threat to the environment, aesthetic problems, and a health issue which needs to be solved. Using rubber crumbs as a substitute of fine or coarse aggregate by grinding the tires is a viable option, not to just make use of the scrap tires that are left to pile up in numbers, but to also preserve the natural materials in a conventional concrete mixture and to potentially improve its properties. The use of rubber crumbs as a concrete constituent is properly named as rubbercrete. For the second, the ceramic tiles. Ceramic material waste contributes about 54% to construction and demolition waste, which is already a concerning problem, as C&D waste is the major contributor of the highest percentage of waste worldwide of about 75%. Wastage of ceramic materials is a growing issue, as they are not recyclable or used in other forms in the present time, and is only stockpiling and also causing environmental and disposal problems. This is because ceramic tiles, just like scrap tires, are non-biodegradable products. However, the properties of the ceramic material being durable and highly resistant to any degradation force makes it a suitable choice to be used in concrete. Not only does this produce a product that is focusing on it being more economical, it also affects the properties of fresh and hardened concrete, and it is important that it subsequently solves a part of the issue of managing ceramic waste. The methodology of these researches. Number 1, for the rubbercrete. In the study of rubbercrete, before the rubber crumbs of a tire scrap could be used as an aggregate as the constituent of concrete, the tire scraps are to be reduced into smaller granules of sizes ranging from 75 micrometers to 4.75 millimeters, while removing the steel, fibers, dust, and any contaminants found in the tire and leaving only the rubber particles. Cryogenic grinding and cracker mill process produces the most desirable size of the rubber crumbs, hence making it the most common method used in production of rubber crumbs, therefore making it the method of choice for the grinding of the tires. Different properties of the rubbercrete, being it at its fresh state or hardened state, were tested. The rubber crumbs were used as a partial replacement of fine aggregate in the constituent of concrete, with different replacement levels and not completely replacing it. For the ceramic tiles, in this study, the waste ceramic tile is beforehand grinded before it was graded, and after that, a plethora of tests were done for both concrete containing natural aggregates and partial ceramic tile aggregates. In the first stage of this study, ceramic tile with percentages of 0 to 50 were substitutes for natural coarse aggregates. Then a comparison was made between slumps, unit weight, and comprehensive strength of a new concrete and sample references, which are the normal concrete. Next, the optimum percent of ceramic tile aggregate and the water to cement ratio were determined. Lastly, flexural strength of the optimal concrete and the reference concrete were determined, and there were 18 types of concrete mixes that were prepared in order to carry out the research with different amount of substituted ceramic tile, but the concrete mixes were produced by keeping the proportion of 1 to 1.5 to 3, which are the proportions of cement to fine aggregate to coarse aggregate, and the cement content stays the same, which is 300 kilograms per meter cube, and the quantity of fine aggregate constant, and changing the proportions of coarse aggregate with waste ceramic tile aggregate with the water cement ratios of 0.4 to 0.5 and 0.6.
So the first one, we have the rubbercrete. So there are two properties of the rubber kit in its fresh state. So the first one is workability, and the second one is the unit weight density and air content. So we know that rubbercrete is related to concrete, and the workability of the concrete seemingly improves along with its consistency, and this happens maybe due to the hydrophobic nature of the chrome rubber, as it will repel water, which results in increasing amount of water available to react with other materials in the concrete. And as for the unit weight, density, and air content, the unit weight of the rubbercrete reduces due to the low density of chrome rubber than fine sand. Air content of the rubbercrete increases in air content because the chrome rubber's non-polar and hydrophobic nature, which entraps air on its surface. So this table shows the effect of partial replacement of chrome rubber on hardened properties of rubbercrete. So we have four properties of hardened state. So the first one is strength, deformation, durability, and non-structural performance. So these are the replacement, percentage of reduction, and the percentage of increment for these four properties. Next is about the ceramic tiles. So these are the effects. So the first one, we have the workability. So for the workability, the test that was used for the workability of concrete is slump test, and the result of the slump test is that we can see that the increment of the water recement ratio of 0.4, 0.5, and 0.6, and between this number, 0.4 to 0.5 is considered as low, while 0.5 is considered for good enough for a concrete operation, and while for the degree of workability, it is 0.6 as it is good for concrete operation. The second one, we have the concrete density. So as for the concrete density, the unit weight of the cement and the amount of ceramic tile substitution are in contrast. For example, as the unit weight of the cement decreases, the amount of ceramic tiles substitution will increase. We can see that the tiles causes a decrease in unit weight, and it will helping with load bearing capacity of structures. Next, we have the compressive strength. The compressive strength is a bit different from the normal concrete of conventional constituent, because for compressive strength, it was observed for after 28 days in comparison to the normal concrete, and there was no reduction in the strength of the concrete, but there is an increase in its compressive strength. And as for flexural strength, we can see that based on the testing results, the flexural strength of the ceramic waste concrete generally increase with the increase of quantity of ceramic waste in the concrete.
For our discussion, the two concrete of substitute aggregates of rubber crumbs and cement tiles both have implemented and effected different properties towards the concrete. Both are compared to a normal concrete of conventional materials as a reference. The compressive strength decreasing with a peak of 78.95%, the flexural strength decreasing with a peak of 40.74%. An increase of performance durability, most notably a peak increment of 198.3% for impact resistance, 183% for the ultimate strength, and 193.2% for the toughness. Now for the ceramic tile substitute, it is only viable for concrete operation for concrete with water cement ratio of 0.5% and 0.6%. Other than that, positive results are seen, as not only does it lowers the unit weight of the concrete and a impactful increase of the compressive strength. Also shows a major increment in terms of flexural strength with 32.2% in comparison with normal concrete. Researchers truly made an impact of making efforts not only preserving the natural resource of the earth, but to study on the change of properties towards concrete that these materials impacted. The researchers covered all of the possible bases except maybe actually using the product in an actual practical work and investigate how it holds up against time and natural forces of the environment. In a conclusion, both ceramic tiles and rubber scraps are a viable option to be used as a partial substitute of aggregates, but in actual practical usage might be limited to a certain application based on its new properties caused by the usage of the non-conventional material. But overall, it reaches the objective of realizing a vision of making the earth environmentally healthier, making it more sustainable products using waste materials, and could also potentially be a more cost-friendly option. So for our recommendation is non-biodegradable materials of everyday products such as plastic, glass, and aluminium cans need to be the focal points of these studies to further push the envelope of being sustainable and trying to environmentally healthier.